Student, today we are going to see Kirchhoff voltage law, that is KVL, or it is also called as Kirchhoff's second law. The statement of that KVL is, in any closed loop of electric network, the algebraic sum of EMF and the voltage drops is equal to 0. Means in a closed loop, for example, this is the one circuit. This circuit consists of one battery of 10 volt. It consists of two resistors, resistor R1 and R2, and there is one closed loop. In this closed loop, the number of EMF is 1, that is summation of EMF plus summation of IR. IR means the voltage drop. The voltage drop across resistor R1, the voltage drop across resistor R2, that is summation of EMF plus summation of IR is equal to 0. Means in a given loop means a closed loop, that means the shortest path in which the current will complete its current flowing. For example, point out the point A, B, C, D is the particular loop. In this loop, due to this battery 10 volt, the current will start to flow from point A to B, B to C, C to D, and the current will stop from positive to negative. That is the closed loop. In this closed loop, you have to find out the number of EMF, you have to find out the number of voltage drop, and the summation of voltage drop and the current drop, voltage drop and the EMF is equal to 0. And in this way, we are going to see equation will be 0 or not by solving one problem. Okay, so basically this KVL is based on conversion of energy principle. Conversion of energy principle means the number of sources in a closed loop, that is summation of V is equal to V1 plus V2, voltage drop across each equal to 0, that is summation EMF is equal to 0 in closed path. It means KVL is based on conversion of energy principle. So basically we are going to explain how the Kirchhoff voltage law works. Simply, the circuit consists of one battery, that is EMF, labeling as a voltage V 10 volt. The resistor R1 and resistor R2 are connected in series. How it can be in a series? When current will be common in the circuit, the current flowing in the circuit will be common, that is current is common. The same current will flowing in R1, the same current will be flowing into resistor R2, hence is the series combination. So in any closed loop, for example, we are going to mark out the particular point A, B, C, D. Now we are going to apply the Kirchhoff voltage law for the loop. Now before applying the particular loop, we must know some sign conventions and the basic statement of the KVL. Before applying the KVL to the loop ABCD, there is one closed path. Closed path will find the current flowing path, and you have to take or you have to trace the loop in a clockwise direction. You have to trace the loop in a clockwise direction. If the loop direction and the current direction are same, then take minus sign. How it will be? We will be see with the problem solving. So summation of EMF plus summation of IR is equal to 0. But in this circuit, summation of IR means the voltage drop. There are two voltage drop, resistor R1 and resistor R2. Across that, the voltage drop will be there. The voltage drop will be calculated as V1 is equal to I into R1. V2, another voltage drop, V2 is equal to current I into R2. The similar way, there are two voltage drop, that is summation IR is equal to I into R1 plus I into R2. And the summation of EMF, that is number of summation means the total combination of supply. There is only one single source is applied as a 10 volt voltage source or the EMF source, hence the EMF or V is equal to 10 volt. Now by applying the sign conventions to the loop, we can find out the particular equations. Now Before start with the sign convention, please observe the circuit diagram. In this circuit diagram, the current direction and loop direction, for example, the current is flowing from positive to negative terminals, from point A to B, B to C, C to D, and the current will stop at the negative terminal of the battery. The current direction and the loop direction are in the same way. Hence, the sign convention will be taken as a minus sign in the equation. And if the battery direction, or if the current direction and the loop direction are opposite, then take plus sign in the equation. So we are going to apply the current signs. Similarly, the sign conventions are also for the voltage source. If the loop direction and the battery terminal start from negative to positive, the loop direction firstly touch the minus sign and then touch the positive sign, it means that is rise in potential. If the loop direction touch minus sign firstly and then it will minus to positive, means it will grow from negative to positive, hence it is a rise in potential. And if the direction of battery change, that is loop change or the battery of direction change, means the loop direction is from positive to negative, means positive to negative, that is fall in potential, you have to take the minus signs. So this sign convention we are going to apply and we can solve the problem. Now the direction of loop and the direction of current are same, hence take the minus sign in the equation. See there's the circuit diagram. The direction of current and direction of loop, direction of current and direction of loop are same, hence take the minus sign in the equation. Similarly for this current, means you have to find out the voltage drop. There are two voltage drop, so we have to find out the equation summation IR, plus you have to find out the equation for summation EMF. So now we can apply the same equation. For example, equation for the loop direction of this current with resistor are loop direction and the current direction are same, hence take the minus I into R1. Similarly, the direction of current and the resistor, the direction of current flowing through the resistor R2 and the loop direction are the same way or in the same direction, you have to also take the minus sign. If any one is in opposite direction, then you have to go with positive sign. Okay, so in this particular current, in this diagram, the current will be in a downward direction and loop also going to be traced in a downward direction, so you have to take the minus signs, plus hence the equation will start with minus I into R1, this minus I total current into resistor R1. Similarly, the current I into resistor R2, hence take 2 times minus I1 into R1 minus I into R2. Why are we going to taking minus I common? Because the single current will be, or series current will be flowing. Series current will be flowing in the loop or closed path. Now, after find outing the summation of IR or voltage drop, now find out the voltage drop. There is only single voltage drop and the loop direction firstly touch. During this loop, the loop direction firstly touch the negative terminal of the battery and then positive, negative to positive, hence you have to take as a positive or rise in potential. The similar way you have to take V is equal to 0, V as a positive, and the total summation will be 0, that is summation IR plus summation of EMF is equal to 0. Now this equation we can write in the same way, summation of EMF plus summation of IR. There are two voltage drop. Now put the value, of particular values of resistors, value of voltage or EMF in the equation, then plus V. Why are you going to take the plus V, positive V? Because the loop direction firstly touch the negative to positive terminal, that is rise in potential, hence we have to take the positive sign in the equation, hence the plus V, that is nothing but 10 volt, minus I into R1. We know that the value of resistor R1 is 5 ohm. We know the resistor R2 having the same value of 5 ohm. So we don't know the current, total current I. Means by using this KVL we can find out the loop current. So the equation will be 10 minus 5I. I is common because the single current is flowing in the circuit, minus 5 into I, because there are two resistors with having the same value. Hence the first voltage drop I into minus 5 I1 minus 5 I1. Hence we have to take 10 minus 5 I1, this is the first voltage drop, minus another voltage drop is equal to 0. This is the equation as per KVL statement. Now we can solve this. So by solving 10 as a 10, minus minus will be minus, and the equation will be minus 10 is equal to 0. Finally we can find out the current I is equal to 1 ampere. 10 minus 10, how it can be calculated? This 10 will be shifted another side, minus minus get cancelled, and the current will be 1 ampere. Now this 1 ampere current we can easily find out by using the logic of KVL loop directions. But how it can be measured, or how we can verify the particular KVL? So we know that summation of EMF plus summation of IR is equal to 0. To put down the value of particular values. Now we know the value of I is calculated as 1 ampere. Put the value, V is equal to 10 minus 1 into 5 ohm minus this current I is equal to 1 into 5 ohm. Now put the value of each. The current will be 1 ampere. Hence 1 into 5 is the minus 5. 1 into another value of resistor R2 is 5 ohm. Current value is the same, 1 ampere we have calculated. That is minus 5 is equal to 0. That is 10 minus 10 is equal to 0. Hence we can say that summation of EMF, that is 10 volt, plus summation of IR, there are two voltage drop IR, 5, total will be minus 5. Means the summation of EMF plus summation of IR, both the value are same, and it will get the cancellation, and the equation will be EMF plus summation of IR is equal to 0. In this way we can verify the Kirchhoff voltage law. But sometime the question may be arise, the current I is really goes through a 1 ampere. So we can solve once again. Suppose the two resistances are connected in series. The total resistance RT will be R1 plus R2, because both resistance are connected in series. Hence 5 plus 5 it will be 10 ohm. The total resistance will be RT is equal to 10 ohm. Now we can find out the current I is equal to V divided by RT. Now the current, we know that we are going to calculate the current I by using simple Ohm's law. So I is equal to this, we are going to find out this current I is equal to must be 1. So V is 10 volt divided by the total resistance RT is 10, that is 1 ampere current will be going to be flow. But this is the simple method. By using Ohm's law we can find out the total current flowing in the circuit. But by using KVL, that is summation of IR plus summation of EMF is equal to 0. By solving this by solving this Kirchhoff voltage law or equation, by solving this equation we can find out the loop current, and the loop current is similar or the same as per applying Ohm's law and other things. So we can lastly verify that the summation of EMF plus summation of IR is equal to 0 if the total voltage drop and the total EMF is equal to 0. Then how to use the particular Kirchhoff voltage law? We can solve with the number of one or more than one loops, 1, 2, 3 loops, maximum 3 loops or 4 loops problem will be asked in exam. So according to that we have to find out the different loop the different loop connections, and according to that we have to find out the different loop current, and in this way we can solve the number of problems by using Kirchhoff voltage law. If this video is like, then in next video I will solve 2 or 3 loop KVL problems. Thank you.